Hey everyone, welcome to Graphing Rational Functions Part 4. This is where we're going to be finding the domain and range. This is Nicholas JMV. So today we're going to be finding the domain and range of rational functions from either a graph or an equation. So let's go ahead and start on the graph. So we're looking for the domain and the range here. Okay, so there's two things we want. We want the domain, we want the range, and they give us the graph. Okay, so that's nice of them to do. So the domain deals with your x values, the range deals with your y values. So if we look for the domain, we're looking horizontally, left to right. So we start at negative infinity, we go, and we hit this wall, this asymptote at x equals 0. So here's the x equals 0. And this one is y equals 0. So I can use all numbers except 0. So I write that as negative infinity to 0, and I use that u, the union, from 0 to infinity, and everything's in parentheses here because I can't actually include 0. It would make my function undefined. So there's my domain. The range now is all possible y values, and you can see it breaks into nice sections. I have this section here in the top section. The only value I can't use is 0 for y. So it's all real numbers except 0. So in this case, this problem has a domain and range that are the same. We just can't use 0. So there you go. In example 2, we get a little more complicated piece, and there's 3 portions for the domain and the range. So let's go ahead. We're going to highlight. We want the domain and we want our range. Okay, and we're going to write this. Notice if you look horizontally, left to right, you have one section here, a second section, and a 3. So my domain is going to have 3 pieces here. Okay, so let's look at each piece individually. Starting with box 1. Okay, so we'll look at that and say, all right, well, we go all the way from negative infinity and we stop at this vertical line, and it's at x equals negative 2. So x equals negative 2, and this one's at x equals 2. Okay, so I can use all numbers from negative infinity to negative 2. And that's, I guess that we can call that, that's box 1, portion 1. There it is, there's 1. We got that done. Now we got to look at 2. So we're going to put in union. What else do we have? Well, in position 2, we go from all the values between negative 2 and 2. Look, there's a graph here. So it's all positions between negative 2 and 2. Okay, we're going to run out of space. And so that's going to be in union with the final piece, piece number 3. So we got 2, there's 1, here's 2. And our final third piece is from 2 to infinity. So that has 3 pieces. Notice how there's 3 sections and 3 sections up here. So there's your domain. The range has only 2 sections. Okay, and again, this is our y equals 0 line. Okay, so we can use all real numbers except 0. And so that's how we write this. Again, zeros get parentheses because you can't have 0 be a part of the output because there's a dashed line at 0. So that's how we do it from a graph. You can try to break it into sections if you want to and see what that looks like. And a visual representation is nice. In 3 and 4, we don't get a visual representation, okay? And we might run out of space here, but I'm gonna actually go ahead and kind of make a cheat graph here for myself. Okay, and if I want the domain and range, I have to look at the vertical and horizontal asymptotes. So I'm actually going to start with the range here first. It's a little bit easier. Notice how the powers here are the same. They're both the denominator has a larger power. It's degree 2, numerator is degree 1. That means the horizontal asymptote is y equals 0. So if I sketch that in over here, and I looked at my 2 sections, 1 and 2, my range is from negative infinity to 0, okay, in union with 0 to infinity, okay? And there's my range. My domain is a little bit more challenging. I have to look at the vertical asymptote, okay? So my vertical asymptote is when you set your denominator equal to 0, okay, and you get, I'm going to factor out a negative 4x, Okay, and I'm left with x plus 3. Okay, so I have x equals 0 and x equals negative 3. Those are what might make my denominator 0. Those are my asymptotes. So look, I have a 0, 1 here, and 1, 2, 3, and 1 there. So again, I have 3 pieces. So my domain goes from negative infinity all the way to that vertical line 0, okay, including numbers between 0 and negative 3, and finally negative 3 to infinity. Or excuse me, positive 3. That should be positive 3, positive 3. My fault. And so that is your domain, and that is your range. So there's your domain, and here's your range. Final example. Find the domain and the range of the function below. Okay? So if I wanted the vertical asymptote, I set the denominator equal to 0, and this helps me with my domain. So if you solve that, you get x equals 3. If x is 3, undefined, so that means my domain is all real numbers except 3. And notice in this one I didn't actually draw a graph. Okay, it's everything but 3, and there we go. Notice again, well, in this example, the powers are the same, the degree, they're both first degree. So my horizontal asymptote is at y equals 1/4. That means I can use all numbers except 1/4. And so that's my range, all real numbers except 1/4, and that's how we go ahead and do that. So that is domain and range from a graph and from an equation. So if you have any questions or comments, please type them below, and we'll see you next time.